Good evening all, and welcome to the lecture session of object-oriented programming using C++. And in this session we are discussing operator overloading. Along with this, the type conversion of the user-defined type. So initially, just to give an idea what actually overloading is, just have a look up this look at all these statements. Okay, let's say we're writing in C++ that int a comma b comma c, we are declaring three variables. Fine, absolutely fine. Then we are doing c equal to a plus b, we are adding and two integers and storing another integer. Fine. Now let's say we've declared three distance objects. Okay, I think we already discussed about the distance class, the example of distance class in my previous lectures. I would like you to please refer that example. So if you refer the example, so using that class of distance, we can create three objects like d1, d2, d3. Now when it comes to writing like this, d3 equal to d1 plus d2. So the logical meaning is that I'm going to add two distance d1 plus d2 and store in d3. And we have already done this using functions. Okay, the member functions, we already done that. So is it okay if we write like this? Definitely not okay according to C++, according to the basic syntax of the programming language. Why? Because the error is here that generally the operators like plus, minus, multiplication, division, all are defined to handle the operands which are of primitive type. Okay, means see, it's okay when I write c equal to a plus b because a, b, c are the primitive types. It's an integer type. But when it comes to distance, it's a user defined type. The class that we define is user defined type. So for user defined type, it does not work directly. But yes, we have a provision that we can achieve this. So what is the objective here? You see, instead of writing d1, d3 dot add distance or just add by parsing d1 d2, okay, that looks like a function call, but when you write like this, it actually gives a logical meaning and the program becomes more clear. So since this is not only defined by primitive type, C++ as an object-oriented programming language support this feature that we can use plus or the operators not only for primitive type but also for the user defined type. But for that we need to do some additional task. Okay, so when we are able to do that, then we say that this plus, minus, whatever operator which are supported are overloaded. Okay, this is called over. So they're doing their basic task, that they're able to add integer, float, double, etc. Along with this, we are giving an additional task that it can also add two distance, it can add two time objects, and so on. So this is the idea behind operator overloading. So the aim is to make the user defined data types behave in the same way as the built-in data type. And that is adding two variables of user defined data type with the same syntax that is applied to basic data type. Okay, I think everybody knows that we can still do an addition operation and we can get the result by using a function that we have a very powerful tool, that is function. But to look like, to behave exactly the way, to make these operators behave exactly the way they behave for a primitive type. So it look like that. Okay, it exactly work like primitive type. Okay, it look that, okay, yes, we can do a plus b where a and b are primitive type, but also we can do a plus b where a, b could be of user defined type. So the mechanism to provide new definition to the operators by associating some additional functionalities called operator overloading. So you must realize these things, that we need to associate some additional functionality, then only we are overloading the task, overloading an operator, or we are providing an additional task to an operator along with its basic task. Okay, so this is the definition of operator overloading. Yeah, there are exceptions. Not all the operators that is defined in C++ can be overloaded. So don't think that I can do everything, I can overload everything. But most of the arithmetic operations and logical operators, they can be overloaded. All right. So there are some exceptions, like the class member, like dot, which is used to refer to a class member. Okay, and also to invoke a member function. Also the member operator is dot star to a pointer, a member referring to a member, which a pointer to a member, right? So then the scope resolution operator, then size of operator, and conditional ternary operator, or we can also called conditional operator. These are exceptions. These operators cannot be overloaded by the way we are going to do that. Okay. All rest can be overloaded depend upon the need. But most important thing, you have to follow by rule. The main rule is that we cannot change the syntax or grammatical rule that govern the use of the operator. So operators use some syntax, we cannot choose that. Means if it's a binary operator, it must use two operands. Okay, not exactly one on the left or on the right. So for example, okay, we cannot use it for other way. So syntax, we are not able to, we cannot change the syntax. Another thing, then when an operator is overloaded, its original meaning is not lost. Okay, the original meaning is not lost. So mean to say that the plus is going to add. Okay, previously it was adding integer, floating point, it is going to do that thing. So original meaning we are not going to use a plus for some other task. And only existing operators are overloaded, and new operators cannot be created. So one thing is mind that we cannot create new operators to do our task. Only the operator which are valid, okay, maybe a binary, maybe unary in C++, that can be used. Okay, that can be overloaded. Okay, and we cannot go for a new. Suppose you will say, let me create a new operator like let's say dollar, right? Yeah, dollar is not an operator honestly in C++. So I cannot say that I will use dollar for some other task. So new operator cannot, only existing can be overloaded. Now you must have at least one operand of user defined time, otherwise it's of no meaning. It's kind of, this statement is kind of an obvious thing that whenever you are using the plus, if you have at least one operand is a user defined type of a particular class type, then only there is a role of operator overloading. Otherwise there is no role of operator overloading. Then the overloaded operators must follow the syntax of the original operators. Okay, whatever the way the syntax, the plus is used or minus is used, that should be the same. Like we will use a plus b for wherever and b are in integer type, then we also should use distance exactly the same way or time exactly in the same way. Okay, then when some binary operators overloaded through a member function, the left hand operand must be an object of relevant class. So it will be more clear when we discuss the to define in a function which is responsible for overloading a particular operator, and that is a member function. Then the rule is that left hand side object we can only overload the way that the left hand side object should belongs to that particular class where we are defining the overloaded function. Okay, where we are overloading a particular binary operator. That will be more clear when I discuss some example. Then the operators like plus, minus, multiplication, division, etc. must explicitly return a value because they perform some task. There is an output here because they will result in a new data, so that there should be a written value for that. Okay, explicitly. So the syntax, how we are going to overload an operator. So generally it is achieved via a function. So when I say that, okay, can you use plus to add two time objects? Yes, I can do. Then how will you do that? Yes, I will tell compiler that when I write a plus with complex with, let's say, this a time object or a complex object, it should do the task which is I defined within a particular function. Okay, so the same way, so when I say can you overload minus? Yes, I can overload minus for, let's say, time class object. So what to do? So because compiler have no idea, compiler knows how to add, subtract, multiply the primitive objects. When it comes to time, it's your class, so you must tell compiler what you should do when you encounter a situation or when you encounter a statement where plus is used along with the operand of time class, or plus is used with along with the operand of complex class. So to tell compiler what to do, we must explicitly define an operator function. So a function which will actually automatically involve, just like our constructor, or we have seen the constructor, destructor, we have seen that when a declaration is done, automatic for initialization a particular the corresponding constructor is invoked. Similarly here, when the compiler encounters such situation, it will find a match of a equivalent operator function which can do this task, so it is going to invoke automatically. So for that we have to tell compiler what it should do. Okay, so we can do this via a function. Actually this is again a special type of function that is known as operator function. So we don't call them as just a simple member function or a simple function. They are operator function. Okay, just like constructor, destructor, there is something different. Okay, now the syntax is everything remains the same. It will have a referent type, and definitely when you define, generally we define it outside the class, we don't define inside the class. Okay, mostly we define outside the class. So we provide the scope to which class it belongs to. If it is a member operator function, there can be two types. We'll see that. Okay, member operator function. Also we have seen the concept of friend, so also possible that we can define a friend operator function. Okay, so in this case what happens, then operator, then the most important is that we will use the keyword operator. Okay, when you use keyword operator, it understands this is an operator function. The compiler automatically understands this operator function. Okay, and if it is defined within a class, so it's a member function. Okay, then OP, actually the function name or the operator that we are going to overload. So here instead of OP we will mention plus or minus, or let's say ampersand, whatever operator we are going to overload. Okay, then the arguments, just like the function. Then inside this function we tell that when this particular function is called, what to do. Okay, means if it is a plus, so whatever the object will be passed, we will going to add them. If it is a negative minus, so we're going to subtract them. Whatever task will be, actually the task will be defined. So what to perform when we write the operator, sorry, along with two objects, this task to be defined within the function body. We'll see examples. Okay. Then more about operator function. So operator function can be defined either a non-static member function of a class. Okay, and there are it is possible that it can be a member function for a particular class. That means if we are defining an operator function inside a class, that means we mostly it is associated for that with that class. Okay, means it is going to overload, maybe at least one of the operand is going to be of that class type, right? That's for sure. Okay, and also possible the friend function. When we are going to, friend is mostly required when we when we are having an operation, okay, where the left hand side object has to be a primitive type, or both two objects are of different type, mixed mode kind of thing. In that case, generally we need the friend function, but other cases we may or may not use. Okay, if the left hand side object is there is an object of the user defined type on the left hand side, then we can use either one. Okay, so in that case we can use the member operator function. So what is the difference actually? So a member operator function will take no argument for unary operator, because we are applying the unary object on an object which is actually going to invoke this member operator function. So that object is implicitly passed, so not required to pass. But when it comes to a friend function, okay, it will take one argument because that object has to be explicitly passed to the friend function, the outsider function. All right. Similarly, for a binary operator, one object is passed implicitly, so there is only one more object, which is because a binary operator we need two operands, so other object will be passed as an argument. So only one argument for the binary cases. But when it comes to friend function, both the objects, because it's an outsider function, it's not a non-member function, both the object need to be passed as argument for operation. So then in that case it will be two arguments. Okay, so if you see some example, it will be more clear to okay what actually it does. Okay, it's all about a member function or a non-member function. Then an operator function must be a friend function, as I was just telling before, that if the leftmost operand must be of different class or C++ primitive type or intrinsic type. Means when we are let's say for example we are overloading plus a plus b, when a is of let's say a is an object of different kind, where okay of the particular class which you are defining. Say for example we are defining for the time class, okay, and a is not of type time class, or it is it's a primitive type class. Okay, so if a is not, if suppose you are thinking about a time class, we are trying to overload a function in the time class, and when we found that left hand side operand is neither of time class type nor okay so actually it's not it's either a not a time class type, or maybe it's a primitive type. In this case we have to define a primitive friend function. It cannot be achieved by overloading cannot be achieved by a member function. For member function, the left hand side or maybe the only object, so for a particular operator should be of the particular class type. Okay. Secondly, an operator implemented as friend function must be explicitly have arguments for objects. So operator, when you a function we are implementing as a friend function, then it has to take all the arguments. Okay, means all the argument required to apply that operation on those objects. Okay, so here is in a some declarations and no actually say we can say the prototypes for different operator function for let's say distance class. I think everybody is aware of distance class. You can see my example in the previous video. So when I write the first line, let us analyze them. What they will do, you already know. We already know that what a plus is going to add, you know, a plus is going to increment, or e double equal to is going to check the both the elements are correct, same or not. That's the thing. Let's see how different prototype give the different, means we can from the prototype you can see that what type of function is, whether it's a member operator function or a friend function. The first one, okay, is overloading the plus, okay, and it's a member operator function. So if it's a member operator function, it returns, definitely it's a plus, must return a value, and it is only taking one, because the second the left hand here in this case the left hand side operand is automatically passed. When I write a plus b, okay, that means a is actually invoking this particular function. So a is automatically passed and b is passed as the argument. Okay, same with the minus. Now when it comes to friend is not a member function, so both a and b are passed as argument. Okay, both a. So for these two, the plus and as a member, this is an optional, whether we can use member operator function for plus or we can use the friend function. It's an optional, and both can be done. But when it comes to friend, there are two arguments. Now for the second, then for this one here, because you can see easily that the first operand is a floating point type, second is distance type, as I was saying before. Okay, because the left hand side operand is a float type, no way it can become the member function of the class. Okay, member function of the class. So in this case we have to define a friend function, because it is like a plus b, where a is a float, b is a distance object. Okay, So next comes the unary operator. Okay, so we see that this is a unary operator, and this is not a member function. Okay, because unary operator also updates some information. Okay, so we return the value here. Okay, so some operator, the operator functions, here it return a value. Okay, and it takes the explicit object, the only object, as an argument. Okay, next comes to the unary minus. Okay, it's only negate a particular object, right? So if it is x, it will be minus x. So again, it's a friend function, it is not a member function. All right, then the operator double equality. All right, so double equal to, and it is a member function. All right, and the output of this is always true or false. Right? We know that whether two distance objects are here, we are trying to match two distance objects instead of any primitive type. So if one object is passed implicitly to the when it is invoked, the left hand side object, and right hand side object is passed as an argument. So the return type is bool, whether it is true or false. That we know that always double equal to returns a true value. Okay. Then so this similarly here, same, it returns a truth value, but it's a friend function. Now this exactly operator function is implemented as a friend function by passing two distance object to compare whether two distance objects are equal or not, same or not. Okay, so this is how are the prototypes, because then it's your job to apply what action to be, what are the statement to be added to perform this task. But this is the prototype defines an operator function, different operator functions. Okay. Now, a quick syntax of unary, when you use unary operator or binary operator as a friend function or as a member operator function. So for example, let's say unary operator you are using, let's say OP, and so OPX generally it is like postfix. So and prefix, and this is like prefix. We use double plus plus and plus plus and minus minus as prefixes and postfix. All right. So if for this we have to do, for example, let's say for unary operators, we write like this operator operation. When we pass the value x, it is a friend function. Now when we call, how to go to call, so it is automatically x dot operator, okay, with operation is the member function. This is how the friend function is called. This is how the member functions. Whenever we write like this, it is automatically converted into the invoking operator function will look something like this. Now for binary operation, for x operation y, okay, if it is a member function, the call is something like this. Means, as I was saying, the x is passed as an implicit object. The first operand, the left hand side operand, is passed as an implicit object, and the second operand, the right hand side operand, is passed as an argument. All right. Now for the friend function, both x and y are passed as argument. All right. So little bit, you have to be a little bit careful when you're using the member function, that you are making sure that the here, suppose we are writing here, so the particular object is passed as an implicit object, okay, for these cases. And for these cases, it has to be the left hand. When you are defining as a member function, this x should be of the same class type. If x is of different class type, we cannot define member function. We have to opt for operator function, operator as a member, as a friend operator function. So the first example, the plus, okay, overloading plus for a distance class to add to distance, and this is by one argument, mean by using a member operator function. So we already know, so distance class, the member feet and inches, then these are the two constructors. One is the default constructor and parameter constructor with the initializations. Then show distance to print the distance in the feet and inches format. All right, we have already defined this function. There is a small function that we define inside. Now here is the declaration, the prototype of the member operator function. All right, so because it returns an output, so it has return type has to be distance, then operator plus distance. It will take the second argument as a second object as an argument, right? So here is the complete definition of the function. So we are defining, because it belongs to the distance scope, this is must, all right. And the second argument is passed as d. So here we are going to use, just like other we refer other objects, we refer with the help of d, we are going to refer the second object. So what do we do? Simply, so let we take some temporary value f is the feet value of the first object added with the feet value of the second object. Similarly, inches of the first object added with the second object and stored into temporary values f and I. Now if I is greater than or equal to 12, we simply subtract 12 from the I and we add one value to the, we increment the value of feet, because we are carrying carry forward of one value. All right, then using this f and I, we are passing an object. Okay, so we create a temporary object here. We are not naming it, right? So it is indirectly calling the parameterized constructor. So distance fi. So create an object of distance fi first, then return this object. Okay, so this is how this functions. So then once we define a member operator function like this, we can use distance the plus operation like this. So you can see that d3 is initialized by the sum of d1 d2. Okay, so then we are printing all these three. Then again distance d4 is initialized, okay, and declared and initialized by the sum of d1 d2 d3, and you can show. So let's see this example. Let's run this example and see. Not particularly this example. I think I might have another example for this. So related to the related to the unary operator, binary operator. So this should be somewhere here. So yes, so let's see S5 binary overloading. All right, yeah, it's for distance only. So same thing. So you can see it's all plus minus, everything is defined here. All right, so this is the function. Okay, so here is the member function. I think I put in the comment to demonstrate the friend one. So we'll see this one by one. Okay, let me complete all examples first. Okay, right. So next is two arguments. When here it is not mandatory, because we have one because when adding two objects of distance type, definitely the left hand side object is of distance type, so no problem, we can define the member operator function. Also we can go for friend operator function. So where here is, it's a global function defined at the global level, its return type is distance, and operator plus indicate that it's an operator function but not a member. It's clearly mentioned that it's not a member. So it takes explicitly both the distance object, both the operand d1 d2 as an argument, and the logic is same. Everything is same. So what you have to do? Only thing that we have to declare this function as a friend of this class. So otherwise it cannot access this d1 feet and inches, the data members, private data members directly, right? That is the only purpose. That's the only purpose, because we are operating, we are performing operation on two objects, so we may need to refer to the members, right? For that we are making it friend. So friend distance, return type distance, then operator plus distance comma distance, indicating that this function is a friend now. Because it's a friend, it can access the. Now if you can access each member. Okay, it's sometimes it's tedious task. If you like, you have defined a function to refer to get the value of each member of an object, then you may not define this as a friend function. Okay, you can define an operator function but may not define it, because we are making it friend only to access the private members directly. Otherwise it is absolutely not required. All right, so same thing. All right, it's using the two arguments. Next comes to the unary operator, okay, using member function. So you can see void operator plus plus, because you know that because it's a member function, the only object is passed explicitly, right? And yes, now question comes, because we have operators like a prefix and a postfix, how to distinguish it? We generally distinguish by passing an integer keyword. All right, when you pass an integer keyword, it indicates that this is for postfix. Mostly the task is same, but to implement both of them, to compile the compiler shouldn't be confused. So this is the syntax, that when you are overloading the postfix, increment, okay, then it is should be int should be passed just to separate from the prefix increment. All right, so but other things remain the same. Okay, so because the object is implicitly passed, any changes made to the object will be reflected, so we don't need to return here. Okay, so both void will work, no need to return in these cases. Okay, because of only one object. Okay, rest is you know everything. So you are increasing the feet value, increasing the inches value. If at all increases, inches value becomes 12 because we are incrementing by only 1. So then we set to inches value to 0, and then we what we do that we just increment the feet value. That's it. All right, this is how we do it. All right, yes. No, okay, fine. Let us go to the example now. Let us see, we can study the example in detail and see. All right, so show distance is here, and I think these are all parameterized constructors. Yes, when we pass a no, there are two parameterized constructor. One may take the both integer and float value. Second may takes only float value to convert that float value again back to feet and inches. So you can see that we have provided two parameterized constructors. Okay, then show distance to print in the format of feet and inches. All right, now first let us see the because we'll focus on the plus, the negative, the minus, you know, minus operator is almost the same, right? So we'll focus on the plus part. So first is I'm enabling the member operator function for adding two distance object. I'm putting the friend as a command because I'm demonstrating both of them. And let me open this one so that we can call the member operator function for plus, and we have to put the friend operator function for this and comment this one we have to put in the comment for the first time. Okay, done. So next I think depend upon the our I have also enabled here with adding with a float. Okay, so yes, I can add a float too also. Okay, to add distance. So this is the member function. Next member function, adding a distance with a float, where float is the second operator. Okay, second operand. All right, so when then why simply add that float to the inches part. If the inches part goes beyond the 12, I take the carry to the feet part. That's it. Okay, and we create the object return. That's it. Okay, and here exactly the other way, because you know we pass here this is not a member function. So for that we have defined a friend function when I'm the left hand side object is not a distance object, means I am first one this particular function is using a distance object with the float. Now means distance plus float value, here float plus distance value. For that I need to define this one. This is generally we call mixed mode operator overloading. For the, because we know that I was saying that the left hand side object is not of distance class object, so it has to be a friend function. We have to define a friend function, and here it is. Okay, so this is the friend function. Okay. So adding a float to same thing. The logic is almost same as this one. Okay, and then we have a the negating a particular object. It's a unary operator. All right. So then this return type is not required. Absolutely, I don't think it's not required because only object is passed here. Fine, but no harm because I'm not returning anything. Fine, it still works. Okay, because implicitly it returns one object. Okay, just to indicate that you can still work, but to indicate that the implicitly an object is returned here, we can mention here. All right. Then less than, for checking whether the object is less than or the second object or not. If it is less than, return true, otherwise false. Okay, that's the point. So it is, I think logics you know very well. To compare to distance, I don't think I have to do that. Okay, so let's run it, see that how it works. So how we use it, see that first is we created two distance object using the parameterized constructor. Okay, one with the 10 feet 6 inches, 11 feet 5 inches. Fine. then d3 equal to d1 plus d2. Okay, then we print all objects, all d1, d2, d3. Then d4 is created by initializing to d1 plus d2 plus d3. That means because we are using plus 2 time, okay, it will be from left to right. First d1 d2, d1 to d2 will be added, then whatever result will be again will be added to d3. The final result is going to be stored for, so that means the operator function will be called twice here, definitely. Okay, then adding a float to the d4, then we created and created d5 by adding d4 the float to the d4. Then d6 is created by adding a float here. Okay, then I think this here we should if it is, it still work if I can do this way. I will just do this other way so that it is also possible. So 13 plus, because we're going to call explicitly the friend function, 13 plus d5. Okay, it still works because we have also defined the friend function for to do this task. Okay, should work. All right, so let's see then. Yes, let's see what are the CS5 binary, right? So let us run it and see the output. Yes. Oh, sorry, I think I forgot to mention that the object 1 or 2. Okay, so this is actually this is d1, right? D1, this is the d2, right? Then this is the sum of d1 and d2 as d3. This is d3, right? This is d3. Okay. Then this is d4, sum of all of them. This is d4. Then by adding a float part to the file, we get only the float part to the this. I think the float part is let us go back and see. The float part is 9. I think we are adding 9 to this, right? So d5 is added with a 9 value, so 9 inches is added to that. So should be reflected here. Yes, so 9 inches added here, so the resulting d5 is 44 inches, 44 feet and 7 inches, and this is d6. Okay, this is d6, and then later on we are doing some negation operation and all those things. Okay, so negative value of a particular object. So yes, this is how we implement the operator functions. This is a demonstration of the plus, mostly the plus operation. Okay, similarly you can implement all other binary operation and unary operators. Okay, operations. Okay, so I will show the unary operations now. So yes, so here it's for distance we are applying. Now this I've disabled. I've commented the friend version. Okay, this is the member version. You can see that. All right, and similarly we can use for the friend version. All right, so this is how we are calling. This is first we are creating an object with the value 10 and 11. Then first object is called first is post incremented. Then it is pre incremented. We are displaying the output after all the things. Here I have just put a comment. Sorry for that. I have not put the right comment over there. All right. Fine, let's see. S5 unary, right? When I run it, first it will be initialized. So first after postfix, because it's increment by 1, so inches become 12, so 11 becomes 12 and inch part becomes 0. Then after prefix again it adding inch 1, so we're adding 1 to feet and inches, and then if it is inches getting 12, we are carrying to the feet part. Okay, that's it. All right, so this is how the operator functions work. So there are other different demonstrations. Okay, so here is a case where we have to go for a friend function because it actually operates over a multiplication is performed over a matrix object and a vector object. All right, it has, so you have to go for a just quickly have gone through that because everybody knows that when we have a vector, so vector is multiplied with matrix. Okay, simply with the we're taking the row values and multiply, already we get the values. Okay, so we'll we not know that logic, we need to write it. Okay, so here, so you see that we are not given in detail. Just to the most important point is that this particular operator star, where we are multiplying a matrix with a vector, okay, has to be friend function of both the, because in this case we cannot go for a member function. Okay, if at all we go for a member function, that has to be friend of other function. Okay, and somehow it has to be friend as a member function. So it is always better, in this case we can go for a friend function, so that won't be any problem in the syntax. Okay, so what we do here, we take a matrix object and vector object. All right, so we create a new vector, because we multiply will automatically result in a vector type. Okay, so we take the so we travel through the, because we have fixed the dimension here, so for each we take the vector, we multiply the matrix row. Okay, row value for I equal to 0, so row value the row, each row with the vector, whatever vector we have, you can see that vector is multiplied with each row to get a new value. So, and we multiply, and just like matrix multiplication, you know, so and we get the values and store in store. So we'll get at the end, we'll get a vector, right? So first we have a 4 cross 4 matrix, right, and a vector. So when we multiply, each row will be multiplied with a vector and added to get a single value. So there are 4 rows, so 4 rows will result in 4 values, it will result in a vector. Okay, that's the idea. So here it is. So how we call it, we call like this. Okay, we call in this way. All right, so yeah, it is not a complete example, just to demonstrate that for a case where 2 objects are of different type, we use the friend function like this. It's okay, the use of friend function in this way. All right, because here you see that one is of type matrix, another is of vector type. So you can combine, you can do the operation, the relevant operation, the meaningful operation on any 2 kind of operands. Okay, and we can define the corresponding operator function to overload that particular operator. Okay, now comes the mixed mode overloading, as I was saying that. So mostly some example we'll see when this is like, you know, when there is 2 different type, mostly very different type, how to execute these things. Okay, so for example, C, so we can see is a complex object, C plus equal to C1. This can be executed using a member function. We'll scan that both member and friend. Here this also can be used a member function, but this, for these operations, for this operation we have to go for a friend function. So yes, we have some sample examples here. Okay, so you can see that it's a it's a member function, right? So we can define like this, and we can add the real part of this to this. So it's like, you know, updating the, it's like, you know, updating the left hand side object with adding the value of the right hand side object, right? So we are adding the complex values here to get it updated, right? So real part of the left hand side object is equal to the real part object and the real value of the right hand side object. Similar imaginary part is we get it and we return that much, nothing. Okay, because it's about complex object. Okay, I'm not given in detail, so everybody is already implemented a complex class by this time, I think. So it is very easy to understand how it works. Okay, so a double value is always taken and added to the real part, because double value represent a complex number with only real part. All right, that's the point. And we return the object explicitly here. Okay, you see that this object we are returning explicitly here. Alright, so here we are, because the output is stored in the left hand side object, that object is returned. Okay, explicitly the value of the return pointer is returned. Alright, next here it's a friend function, right? Here a friend function, both because it has to this can be a member function, but you are implementing using a friend function. So here explicitly we are returning an object here, and to both the arguments are passed as an argument. Okay, so we do the same, almost the same task. Okay, when it is a double value is added to the to the real part, and it is updated and returned. Okay, that's what we do. So it's mixed mode. So you have to decide when we should go for a friend function, when we should go for when we cannot go for an at all a member function. Okay, whenever we can go for a member function, we can use it, but whenever it's not at all, when it's not at all possible, then we have to take the help of a friend function, means a non member function. So here is an example where we can overload the in-stream and out-stream operator, that is extraction and insertion operator, right? No, that double less than, double greater than, to take any object. So till now we have that use that for only taking input and printing the built-in type only, that is primitive type only. So here is an example that for complex, to take an input and complex object, we can take the help of this. So what we do here, that is two way. Here it has to be friend function. Why? Because when we overload this, okay, we cannot, because the left hand side operator is always the scene object or cout object, right? So for that we have to make this function as a member function of that class. That is not allowed. Okay, so it is not possible for us to define inside, so it has to be a friend function. All right, so we define a friend function. So first object is the outstream object, second object is the complex object, because here we want to print output a complex object. So we actually, what we do generally, we generally give a format here, nothing different, nothing new, but we want to use this operator, this extraction operator, insertion operator, just like the primitive type. That's why we are using it. Okay, so when we use it, so what you should print exactly in this format. Okay, because some object need a little formatting to print it, so we can write it in that format. Okay, so see the first real value plus I, then imaginary value. Okay, then we take the input. So here we are passing this object as a reference. Both the cases we see that, because any update here we can that will be reflected back to the original object. Mostly it is not required here, but it is required here because the object value changes here. Here nothing changes because it only output. It only, there is a change will be done. There will be a change in the output stream object. When it is passed, the stream object doesn't have anything. But when this particular function is executed, it will have the real value and imaginary value in the stream to print in the output device. Okay, that's why there is a change here. So that's why we are taking passing as a reference value, so that any update here will be reflected to the main object. Okay, main function, right? Similarly here, when this will when the input arrives here, it will be updating the complex objects here. Okay, so instead of we can make one of them as a reference also, other one not, but for to look better, to just for a safe side, or to look better, we pass both the object as a reference value. All right, so that it will perform the task. So here C is need to be updated, because the C object which is passed here and which will be returned will have different values. Okay, because once the input is taken, C value will contain some value. So for that we are passing as a reference value, so that any change here to the C will be reflected in the calling function. That's the idea is. Okay, so I think some example is here for this. In one of the example we have it. Let's see. Okay, yeah, that's this is here. So VIS5 complex mix mode. So here mix mode we have that two. You can see these friend functions were defined here to take the input and output a complex object. So we can exactly use the complex object just like primitive object to print the output. So you see that here I'm taking input here two objects using scene operator. Okay, so directly we don't have to like c1.re here, c1. So it is a very simple class, but when the class is very complex, this can be useful. This could be really useful. All right, then we are out printing directly here. We are not okay. So whenever we write like this, whatever format we provide, it is going to print exactly in that format. Okay, so this is the use of the use of overloading the insertion operator and extraction operator. Okay, this is the insertion operator. This we have here, right, and this is the extraction operator. Okay, so you can use this way. All right, let's run it and see for a simple complex objects. Okay, let's say 5, 6. Let's say second one is 4, 3. Okay, so C1 is actually the sum of these two. All right. So yeah, 9 plus 9. Okay, we got this. The first object is a add some c1 is equal to c1 plus c2. Okay, then we add a float value for the, I think sorry, I skipped that part. I'll have to show you, otherwise you cannot understand that part. Yes, so I take a double value, a constant value, and I add to the then c. Okay, so c1, yes, I update c1 by a double value by using the mixed mode operation, where for which we have already defined the functions here. Okay, mixed mode operation. Okay. And for plus equal to also, we have also overloaded plus equal to. All right, both is a member function. All right, so yes, so the c1 is updated with the b value here, and again it is printed. Then a double value x is taken, where we have taken c2 as input, so c2 is updated with this double value and c2 is printed. Then c2 is again updated with the x value again as in the mixed mode, where x is on the left hand side. Okay, so that's why you get in two values of x value. So this is a c2. First c2 added x on the left right hand side, then x on the left hand side. Okay, and this is c1 after adding the double value 10. Okay, so it becomes 19. That's how. So we can do any kind of mixed mode operation using these operators. Okay, so note one point is that this stream insertion or extraction objects function must be a non-member function, as I was telling, as the object of this class complex appear in the case as a right hand side operand. Okay, so and function cannot be part of the class OStream, iStream. So that's why it has to be a friend function. It cannot be a member function. Right. Here is an example of overloading square operator. I think this is for Q class. Okay, so whenever I use square, I can directly print the value of the element. What is the element present in the Q exactly by using overloading. So there is no clear meaning here, but okay, when I'm overloading square bracket, so I can use square bracket on the my Q integer, my int Q object. Okay, any my int Q object. Okay, I can do that, and I can know what is the element exactly at that ith position. All right, so this is the implemented. Okay, simple thing. You can go through that. I think I suggest the readers to go through this example and see and implement it completely. I think I have only shown the part where I have implemented this particular operator. Okay, so you can go for the complete example. This example is taken from the Java complete reference, the C++ complete reference. Sorry. Then the second part is the type conversion. So assignment is a special operator. We know that with complex property. It's an assignment. It can assign from the right hand side value to the left hand side. Okay. When both sides are equal type, compiler does not need any special instruction. But only when they are different, then the compiler need to be informed whenever the compiler is not in a conflicting situations. All right. So think of a situation when there are both for basic types. What happens when they are basic type? When we have a int var and float var. Okay, var 1 equal to var 2, it is okay allowed. Okay, so but sometimes we do explicit conversion for that. Some case it demands for an explicit conversion. All right, so each such conversion has its own routine built in the compiler, but compiler doesn't support automatic conversion for user defined type. Let's say I have defined a vector vec, okay, then a matrix object max. Okay, so I want to convert this vector into matrix 1. Okay, this vector should be treated as a matrix value. Okay, possible, but this implicit conversion is not possible. Okay, directly we cannot write like this. Okay, so if we need such conversion, suppose we want to make conversion directly by using an assignment operator, then we need to define a conversion function. Just like operator function, we have to define explicit conversion. Means when we put a vector object on the right hand side and we put a object of let's say matrix type on the right hand side, we have to tell what the compiler should do. Okay, so there are three types of conversion possible when we are considering type conversion of user defined data type or class type. Okay, so basic to class type. First is that a basic type like an integer or double will be converted to a particular class type. Then class type to basic type. Let's say again from a distance object will be converted into, let's say, float type. Then one class type to another one, which the top example is that a vector is converted into max. So all these things are achieved through different conversion functions. Okay, let's see that. So first is basic type to user defined type. It is easily can be achieved by, okay, so by defining a constructor. We already know that inside constructor this can be taken care of. All right, we have shown an example that. Okay, so suppose from float we have to convert it to distance. Okay, so we can define a constructor. Whenever it is initialized, we pass the float value, automatically this will be converted into that feet in inches value. So and we can call like this, if it is because it's take a single value, already use that, we can do that in discovered equal to this one. In this way we can do that. The d1 equal to distance covered. So when you said d1 equal to distance covered, sorry, there is a typing mistake here. It should be float. Sorry for that, and it has to be float. Sorry. Yes. So yes. So d1 equal to, when you say d1 is equal to distance covered, so automatically it takes care of this constructor to convert this value. All right, automatically. So this can be achieved by a constructor. Second, when it comes to user defined type to basic, like we have a distance object, we want to convert back into float. For this we have to provide an overloaded casting operator. Okay, and actually we can provide by using to be convert into a class type to a basic type. So generally we call this this casting function, whatever you say, a casting operator, okay, or function, they call conversion function. And the syntax is something like this. So it should be operator and then the type. Now you don't mention the operator here, or no operator here. We actually mention the type here. So when an operator keyword followed by a type, okay, and with the function definition, it is understood that, okay, that an object of this class can be converted into this type using the following process or following statements. Okay, so here it is converted into float. So we can, this is the logic for converting into float. It's up to you how you define the logic. So now once we define like this, we can write distance cover, which is a float type, equal to d1. We can write like this. All right, and third type is one class type to another class type. We have example I was showing the fact. So here I will say polar coordinate to rectangular coordinate. I have shown that because we know that we represent a coordinate in terms of rectangular coordinate, this x, y, then polar by a r and a theta, right? Angle, right? So we have class, let's say a rectangle class, I as a rect, okay, which will represent as a x coordinate, y coordinate, and polar will represent as a radius and an angle, right? So yes, so what I do here, when I define, now inside this polar, you see that I have defined an operator rectangle. Okay, when I define an operator rectangle, so it means that I can convert an polar object to a rectangular object. You have given I have provided an instruction to the compiler that what is to be done when a polar object is assigned to a rectangular object. Okay, so I have defined here. So operator rectangle. So that means the polar object is passed implicitly. Okay, and we have to return the object. Okay, always, because the rectangular which will be assigned to the left hand side. All right. So what we do here? We take the polar object. We find the radius and angle. We find r cos theta and store to x, r sin theta and store to y, and we create a rectangular object. And so that's why we have to make sure that it is it's a friend of rectangular. Okay, we have to make sure that we can create a rectangular object. We can call here, sorry, we can call here, no problem here, not required. So it is inside the class declaration. Okay, so what happens, we write like this, and when I write rec, let's say rec is an object, small rec is an object, and pole, okay, pole already given value. So when I rec equal to pole, this pole will be passed as an implicit object to this conversion function, and this pole is converted into a rectangular object, and that object is returned and assigned to REC. Now if you want both way, then you have to define the operator function in both the classes. Okay, so that means when you want to convert a rectangular to a polar, we must define an operator, a conversion function inside rectangular class with operator polar. okay, or just operator polar, and provide the steps that should be done to perform to convert a rectangular object into polar. Okay, that we already know that. Okay, to find the radius square root of x square plus y square, and no tan, we get the theta value. Okay, that's all. So we define like, so we have to define in this way. We can also convert one class type to another class type. Okay, so this is the end of the operator overloading along with the type conversion. I hope all of you got the concept of how we can overload. You can go for practice with many other operators that is not covered to overload them for different class objects. Thank you all.